All of us may have been looking at the Tesla Semi's 500-mile range the wrong way. What could actually challenge the diesel empire comes down to two powerful numbers: around 15 cents per mile, and roughly 30 minutes of ultra-fast charging. While the driver steps out of the cabin for a cup of coffee, the truck can potentially recover hundreds of miles of range without adding significant extra downtime, turning what would normally be idle time into productive charging time. Could this eventually push the internal combustion engine toward extinction in commercial trucking? And will the traditional trucking industry recognize the shift before electric trucks become common on every major freight route? Why could short-haul trucking be the first segment to transition to the Tesla Semi? The first major factor is energy cost. With diesel prices in California exceeding $7 per gallon, a Class 8 truck averaging around 6 miles per gallon can spend more than $1 on fuel for every mile traveled. By comparison, the Tesla Semi can consume electricity costing roughly 15 cents per mile, potentially making its energy cost about 85% lower. That means a truck traveling 100,000 miles annually could save tens of thousands of dollars in energy expenses alone. For a fleet of 100 trucks, those savings can reach millions of dollars each year. That difference is large enough to influence the purchasing decisions of almost any major logistics company. The Tesla Semi can also perform particularly well in urban traffic, where trucks stop and accelerate repeatedly throughout the day. Diesel trucks continue consuming fuel while waiting at loading docks, sitting in traffic, or idling at intersections. An electric powertrain, by contrast, uses very little energy while stationary. More importantly, every time the truck slows down, the Semi's regenerative braking system can recover kinetic energy and return it to the battery. As a result, routes involving frequent stops, which have traditionally been challenging for diesel trucks, can become some of the strongest operating environments for an electric truck. Tesla also addresses another major expense that is often overlooked: maintenance. Diesel trucks require regular engine oil changes, oil filter replacements, transmission servicing, DEF refills, DPF cleaning or replacement, turbocharger repairs, and EGR system maintenance. These recurring services increase operating expenses and can also keep trucks out of service. The Tesla Semi eliminates many of these systems. In addition, regenerative braking can substantially reduce wear on conventional brake components, especially on routes involving frequent stopping. When fuel and maintenance savings are combined, Tesla says the Semi can deliver around 50% lower operating costs per mile in California and nearly 20% lower total cost of ownership across the United States. These economic advantages are no longer influencing Tesla's strategy only in North America. The company has started laying the groundwork for a European rollout by appointing a dedicated business development manager to support the Tesla Semi launch in France, following a similar hiring effort in Germany earlier this year. These moves indicate that Tesla could be preparing for broader commercial expansion across Europe, with 2027 emerging as a possible target period. By then, the Semi is expected to combine its 500-mile loaded range with supervised autonomous driving, giving fleet operators another potential way to increase productivity while lowering operating costs. At the same time, production is ramping up at Tesla's dedicated Semi facility near Gigafactory, Nevada, helping ensure that manufacturing capacity can eventually support expansion beyond the United States. More importantly, Tesla is no longer depending only on projections. It now has real-world operating data. The Tesla Semi fleet has accumulated more than 13.5 million miles, with one truck surpassing 440,000 miles. Even more notable is the reported 95% uptime, meaning the trucks remain available for freight operations most of the time. Around 75 to 80% of service issues are reportedly resolved within 24 hours, while nearly half are addressed in less than 1 hour. For the logistics industry, this is an extremely important metric because a truck earns money when it is hauling freight, not while it is sitting inside a repair facility. These figures help explain why companies such as PepsiCo, Walmart, DHL, and Costco have chosen to deploy the Tesla Semi, particularly on regional freight routes. Their decisions aren't necessarily driven primarily by environmental concerns. They are responding to the economics. When energy costs fall by tens of thousands of dollars per truck every year, maintenance expenses decline, and fleet availability approaches 95%, every Tesla Semi has the potential to generate more revenue while costing less to operate than a comparable diesel truck. In other words, short-haul trucking may not be becoming the first segment to electrify simply because electric trucks are easier to deploy there. It may be happening because the Tesla Semi currently offers some of its strongest economic advantages in this type of operation. With energy costs around 15 cents per mile, approximately 95% fleet uptime, and more than 13.5 million real-world miles, Tesla is building a case based increasingly on operating data. The company is no longer competing only with promises about the future. It is competing with figures that fleet managers can directly evaluate on their profit and loss statements. But what about long-haul trucking? The Tesla Semi is already laying the groundwork for that market as well. If regional and short-haul trucking becomes the first major segment to transition toward electric power, does that mean long-distance freight will remain dominated by diesel? Not necessarily. The real question is no longer whether electric trucks can handle long-distance transportation. The bigger question is how quickly the remaining infrastructure and operational challenges can be solved. Tesla believes many of these obstacles are temporary, while the long-term economic advantages of electrification could remain permanent. One of the biggest criticisms of electric trucks has always been charging time. A diesel truck can refuel within minutes and quickly return to the highway, while a battery electric truck has to recharge. On the surface, that seems to give diesel a major advantage in cross-country freight. However, that comparison doesn't fully account for how commercial trucking actually operates. Under U.S. hours of service regulations, professional drivers cannot remain behind the wheel indefinitely. Federal rules require commercial drivers to take a 30-minute break after 8 hours of driving and complete approximately 10 consecutive hours off duty before beginning another shift. Tesla designed the Semi with these regulations in mind rather than simply treating them as restrictions. Its 1.2 megawatt Megacharger can reportedly restore roughly 60 to 70% of the battery's range in about 30 minutes, allowing the truck to recharge while the driver is already taking a required break. Instead of creating additional downtime, charging can potentially be integrated into the driver's existing schedule. Tesla is also expanding the charging infrastructure needed for long-distance freight. The company plans to deploy 64 Megacharger stations across the United States, including important freight corridors in California and Texas. In partnership with Pilot, one of North America's largest truck stop operators, Tesla is developing charging locations along Interstate 5, Interstate 10, and other high-volume freight routes. By early 2027, Tesla expects 46 Megacharger sites to be operational, creating the foundation of a nationwide commercial charging network. Although the infrastructure is still being built, the strategy is straightforward: install chargers where freight actually travels rather than trying to cover every highway at the same time. Some industry observers believe an even quicker solution could eventually emerge: battery swapping. Instead of waiting for a truck battery to recharge, a depleted pack could potentially be removed and replaced with a fully charged battery in only a few minutes. Several Chinese manufacturers have already demonstrated heavy-duty battery swapping systems capable of completing the process in approximately 5 minutes. That could potentially make the stop shorter than a traditional diesel refueling break once parking, payment, and fueling time are included. For high-volume freight corridors, battery swapping could offer an interesting economic model. Fleets operating fixed routes between major logistics centers could exchange battery packs at dedicated facilities without waiting for conventional charging. Instead of focusing entirely on making charging faster, operators could focus on maximizing vehicle utilization and keeping trucks on the road for as much time as possible. Tesla has not announced battery swapping for the Semi, but the rapid development of this technology elsewhere shows that the industry's long-term solutions may extend beyond fast charging. Meanwhile, Tesla's manufacturing progress suggests that the company is preparing for demand far beyond today's pilot fleets. Production at the dedicated Tesla Semi factory in Nevada is moving toward an annual capacity of around 50,000 trucks, potentially transforming the Semi from a limited demonstration program into a true commercial product. At the same time, competitors are accelerating their own electric truck programs. Volvo has already delivered more than 5,000 electric heavy-duty trucks worldwide, showing that electrification is no longer simply an experimental niche. It is becoming an industry-wide transition. However, the companies benefiting first from this transition are generally the largest fleet operators. Businesses such as PepsiCo, Walmart, DHL, Cisco, and Costco have the capital required to invest in new vehicles, install depot charging infrastructure, and negotiate large fleet purchases. They can absorb higher upfront costs because they operate enough trucks for lower operating expenses to create substantial long-term savings. The situation is very different for small trucking companies. Independent owner-operators and regional carriers running only a few trucks often face much tighter financial limitations. Even if the Tesla Semi provides dramatically lower operating expenses, the initial purchase price can remain a major obstacle. Smaller companies often have less access to financing, lower purchasing power, and fewer opportunities to distribute infrastructure costs across a large fleet. For these operators, the financial benefits may be obvious, but the capital required to achieve those savings can still be difficult to secure. This challenge extends beyond individual businesses. If only large corporations can afford electric trucks, the transition could further concentrate market power among the biggest logistics companies. Lower energy costs, reduced maintenance, cleaner air, and improved productivity should not become advantages available only to Fortune 500 fleets. Leasing programs, innovative financing, government incentives, and expanded commercial lending could all help smaller trucking companies participate in the transition rather than being pushed behind. Performance, once another major concern, has also become increasingly difficult to criticize. Skeptics questioned whether battery electric trucks could haul heavy loads through steep mountain grades or maintain highway speeds under difficult conditions. Tesla has demonstrated that the Semi can successfully climb challenging grades, such as California's Grapevine, while carrying substantial payloads. Unlike diesel engines, which must shift through gears to build and maintain torque, electric motors deliver strong torque instantly. That allows the Semi to maintain impressive performance even while climbing steep inclines. Perhaps the strongest evidence for Tesla's long-term strategy comes from actual operation rather than engineering specifications. The Tesla Semi fleet has already accumulated more than 13.5 million miles of commercial service, with one truck surpassing 440,000 miles while continuing to operate on its original battery system. Tesla also reports approximately 95% fleet uptime, suggesting that reliability is becoming a competitive advantage rather than an unanswered question. These aren't laboratory simulations or controlled demonstrations. They are results from trucks hauling freight for paying customers in everyday operations. Taken together, these developments suggest that the conversation has fundamentally changed. A few years ago, the debate centered on whether electric heavy-duty trucks were technically possible. Today, the discussion is increasingly focused on how quickly charging infrastructure can expand, how production can scale, and how smaller carriers can gain access to the same economic benefits already being experienced by large fleets. Short-haul trucking may be leading the transition because the economics are strongest today, but regional freight increasingly looks like only the first stage of a much larger transformation. As battery technology improves, Megacharger deployment accelerates, manufacturing reaches tens of thousands of trucks annually, and concepts, such as battery swapping, continue developing. Many traditional advantages of diesel could gradually disappear. The future of long-haul trucking will not be determined by range alone. It will be shaped by economics, infrastructure, reliability, and the ability to keep trucks moving profitably mile after mile. Thanks for watching. If you enjoyed this deep dive into the Tesla Semi and the future of electric trucking, make sure to hit the like button, subscribe to the channel, and turn on notifications so you don't miss our next breakdown. The trucking industry is changing faster than ever, and this may only be the beginning. See you in the next video.